Hello everyone and welcome to this Austmine webinar. I'm Sheldon Varco, Membership Manager New South Wales and South Australia here at Austmine, and I'm joined today by Rajesh Mahanti, Senior Solutions Architect at GE Digital, who will be exploring performance twins in mining and metals. Before we begin, I would like to start by acknowledging that I'm hosting this webinar from the lands of the Gurungai people. I also acknowledge the traditional custodians of the various lands on which you all work today and the Aboriginal and Torres Strait Islander people who are attending this webinar. In Rajesh's presentation today, he will share how companies are using performance twin solutions to safely reduce unnecessary costs and improve production efficiency without uprooting culture, relying on historical data, or taking months to implement. Rajesh has over 17 years experience in various aspects of software implementation, project management, and consulting in sectors such as mining and metals and oil and gas, and currently leads the asset performance management solution design for GE Digital in the Australia and New Zealand region. Following his presentation, there will be an opportunity for audience Q&A. You can use the Q&A button at the bottom of your screen to send your questions over at any time. You can also upvote on the questions that you most want answered. So without further ado, I'd now like to welcome Rajesh for his presentation. Thanks, Rajesh.
Thanks, Sheldon. Hi, everyone. I'm Rajesh Mohanty, Senior Solutions Architect with GE Digital. Today, I'll be talking about the topic digital twin, especially performance digital twin, which has created quite a buzz in the owner-operator environment. I will also touch upon the expectations and requirements of embedding performance digital twins into operation and maintenance landscapes, and also within the technology stack, and see how it can bring value to your organization. Before going any deeper, let's first understand what is a digital twin. Digital twin is most defined as a software representation of a physical asset, system, or process designed to detect, prevent, predict, and optimize through real-time analytics to deliver business value. The original concept came from the desire to take all information available on a piece of equipment or asset and then applying higher level analysis to that information. Digital twin can be implemented at various stages of the asset life cycle, and in its every stage, it brings value to the table. As per ARC, a big research group in the field of software research, especially in the field of asset management, asset digital twin can be categorized into two heads. One is your project digital twin and then performance digital twin. Project digital twins use 3D and 4D models to improve the schedule and avoid errors in the design and build of equipment, plant, or infrastructure. Project digital twin is concerned with the design, engineering, and procurement phase. It takes into account primarily the safety by design concepts. Example, how big or small your manholes should be, how big your dike and containment holes would be, etc. Though it's a very powerful way of modeling plant operations and its scenarios, but it is seen in majority of cases that during handover to operations, this precious information is lost or in most of the cases not utilized in a very holistic manner. This doesn't give an engineer in an owner-operator environment as to how he or she should behave upon encountering some challenges. In short, it doesn't help in establishing a process from an as-built stage to an operating stage. As far as performance digital twin is concerned, performance digital twins use real-time data and analytics to optimize the effectiveness of the resources deployed for operations and maintenance. What we do as a part of G Digital Performance Digital Twins is that we focus on the operate and the maintenance phases. Most of our solutions cater to how do we make most of the asset to meet ultimate business goals and needs through day-to-day operations. Our performance digital twin solution, apart from supporting this phase of asset life cycle, it also helps in integrating information from project digital twin phase to establish a model which helps in improving the performance of an asset. So what does digital twin comprise of? The building blocks of a digital twin are two items: characteristic data and operational data. Characteristic data is that kind of data which defines the properties of the real world asset or process. This includes your failure modes, your design specs, your engineering data, etc. Let's, that, let's take an example of the compressor where the characteristic data would be whether it is a single stage or a multi-stage compressor, what are the failure modes, what are the damage mechanisms, where are the sensors located, etc. Operation data, or how the asset behaves or changes over time, gives you an indication on the historical aspect of the asset. It gives you simulation or real-time data for optimization during production. For example, an operating data would be something like readings collected from the site, operational conditions data, failure data, which is historic, etc. This data may be collected through real-time or through discrete manual interventions. Both characteristic data and operational data are then merged to build an information model. This information model formalizes the properties, relationships, and operations that occur with the two data types. Both the data types are merged to arrive at an analysis based on logics and statistics through an algorithm which runs in the background. The output of this algorithm is an advisory which helps in predicting, diagnosing, and forecasting a failure of an asset. Now, why do organizations move to performance digital twins? We have had a lot of discussions with clients, a lot of discussions with a lot of other industry stalwarts, right? So what we came to know that the primary objective of moving into a more predictive or proactive kind of maintenance regime is that how do they want their business to be more competitive, right? They want their asset strategies to be based on risk management and condition-based maintenance management. But the challenges which they are facing right now is how do they change from a time-based maintenance kind of a maintenance practice to a condition-based maintenance practice. In some of the cases, they have initiated or they have had their tryst with the predictive maintenance concepts, but then they need some more and they want to do it without increasing their staff resources. And last but not the least, they want to have a faster scalability because at the end of the day, they want to predict, diagnose, and forecast equipment failures. Right? Let's first understand the different facets of maintenance practices and maintenance regimes and how the predictive tools help you in moving up the PF curve. We are looking at a very simple PF curve which shows the different operating stages in the life of an asset. You can see that once designed and installed in a facility, this life cycle can be divided into 5 segments: precision, proactive, predictive, preventative, and ultimately your corrective ethics kind of a maintenance regime. Point here is failure is not an event, but a process, and it gives you ample indication well ahead in advance so that we can take appropriate actions to avoid the same and extend the operating life. In extreme right, in green, you have the basic you break, you fix maintenance methodologies. Very primitive, effective, but useful for run for failure kind of a scenario. As you mature as a maintenance organization, you carry out certain preventative maintenance tasks. These tasks include time-based and condition-based maintenance activities. Moving further up, organizations look at avenues to predict asset failures. They look at catching early signs of failure, which would give them sufficient time to plan for a future failure event. It would also give them sufficient time to prolong the failure event. Techniques like vibration monitoring, NDTs, tag monitoring, etc., help here. In precision phase, maintenance practices are enhanced from a process perspective to ensure that assets are maintained in a very robust manner. Tools like RCM, FMEA, root cause analysis, work process alignment are used in this bucket. Ultimately, it helps in keeping that asset in peak condition and in the process avoiding failures. Performance digital twin sits in between precision and predictive maintenance regimes. It takes the output of the precision side and the predictive side into the information model which we talked about and helps in predict, diagnose, and forecasting the data when the failure event alarms is going to be breached. In short, it helps in capturing the signs of failure at a very early stage based on the data collected. Thus, it prevents any kind of catastrophic or sudden failures. The ultimate objective of the organizations who have or are trying to go in this path is to reduce the failure events and also scale up this model to multiple assets. We have come across many organizations who have had a very exciting start to the digital twin journey, but have failed to scale this to multiple asset types. G Digital Performance Twins, by process of standardizing the way we create twins for multiple assets, helps organizations scale up their asset base on this journey, thus giving more value at lowest possible time. We do this by the concept of digital twin blueprints, which we will talk in this uh, in this slide deck. Now, how does this digital twins provide value to organizations? Value from any reliability or operation program bounces off these three pillars, that is, manage risk, improve reliability and availability, and manage cost. Any organization who have been able to keep a right balance between all these three pillars have been successful in deriving value out of their digital twin programs. Let's start with risk. One of the utmost priority of any organization is avoiding catastrophic failures. And their ultimate priority is to prevent loss of life. Many catastrophic failures have happened due to equipment failures, and prevention is one of the most primary drivers for implementing digital twins. Organizations also want to have limited manual intervention in predicting failures and intend to have less risk exposure of personnel to hazardous areas. The second pillar on this value life cycle is your managing costs. Clients have always intended to move out from a forced outage scenario to a more planned outage scenario basis, and this gives them enough time to prepare. Also, as per the Marshall Institute, the study which they created on the cost of planned versus unplanned maintenance outages. So what they have found that unplanned outages or the reactive work are 2 to 5 times more expensive than planned proactive work. Organizations are investing on multiple tools which would help them leap to a more predictive kind of maintenance regime by investing in IoT tools. Also, we have seen that major driver in some parts of this world nowadays is lack of quality resources. So what happens here is that you might be having resources like your reliability engineers catering to multiple sites, multiple assets, right? So when you have got an unplanned shutdown or unplanned outage, it is not necessary that your resources would be available to do your analysis. Sometimes the resources are based out of remote sites or remote center where they're monitoring your assets. So it kind of getting a bit difficult for clients to have the resources on time to do the activity. So in this case, organizations are looking to increase the reach of these resources. Lastly, tools like performance digital twin should be able to ultimately improve the availability and reliability because we are in the business of making money and have availability, have production. One key item is to how to avoid unplanned downtime events. How do we target minimizing lost production events? And how do we do it by leveraging digital twin methodologies? Digital twin helps in removing bottlenecks and avoid these lost production events based on data from the past. So now we have understood what a digital twin is, how can we derive value from a digital twin, but what makes up a digital twin blueprint? Um, Let us understand how do we create a digital twin blueprint. Frankly speaking, we can't sell you a digital twin. Digital twin is born when you apply the information models on the asset, that is your asset, or a series of assets, right? You have to scale up the algorithms, you have to scale up the logic so that it is applicable to multiple assets of similar configurations. So when we talk about the digital twin, we talk about the digital twin blueprint. It is based on the concept of how can I take the information on a particular asset class, use them in a model, and scale that to multiple assets of similar configuration. So what makes up a digital twin blueprint? First and foremost is the subject matter expertise. G Digital uses all machinery expertise from GE, which is you are well aware, GE is a machinery provider and vendor and has got lot of information with them and a lot of subject matter expertise, which helps in creating a very robust digital twin blueprint. This gives G Digital the distinct competitive and superior technology advantage among its peers. Now, using the subject matter expertise, we look at the characteristic data like the failure models, the degradation mechanisms, failure effects, actions, and risks to enhance our digital twin. Once the characteristic data is identified, we then move to the context parameters. We look at the configuration context, we look at the operating context, right? And we also need to understand historical um, behavior. Now, once we have got that, we move to the sensory input and the sensory data aspect of digital twin. We need it to understand the necessary input tag data, and this tag data needs to be configured for that particular asset. This allows us to analyze what sensory data is available to monitor these assets and identify the damage mechanisms. Based on the tag information, we should be able to club this information to have a multivariate diagnostics. Multivariate diagnostics, which is pertaining to a particular failure mode, right, is an essential part of digital twin blueprint because we think no single tag can predict failure accurately. Last but not the least is the engineering specs. We utilize the engineering specs to fine-tune the blueprint to give results as accurately as possible. For example, a position of a sensor in the field can interfere with your diagnostics. This information helps make our model more robust. Once these blueprints are created, it is immediately applied to your asset and assets, multiple assets. In this case, we have taken an example of a mud pump, right? And here, once your digital twin for the mud pump has been created, we have been able to scale up this digital twin blueprint to multiple mud pumps in this particular site. Okay. Thus, it helps you in shortening the time of deployment, and then due to this, you can shorten the time to value. Right? And that is the essence and concept of having a G digital twin blueprint. So, where can we apply this digital twin blueprint? If you ask me, in almost all of the assets across all of the industries, and we have done it. We have implemented digital twins across mining, across oil and gas, upstream, midstream, and downstream, nuclear facilities, aviation, you name it, and we have implemented these digital twins. G-Digital Twin or APM reliability modules includes more than 330 unique blueprints across industries that are readily scalable due to G-Digital's data-driven approach to modeling and configurable model templates. The blueprints are equipment agnostic. We cater to variety of vendors and vendor machinery. They identify a broad range of problems across a wide variety of rotating and processing assets, load ranges, and failure modes across the plant, across sites, across fleets. Now, we have talked about a digital twin blueprint. Let's take a closer look how it actually works. What is the actual workflow around it? What does the digital twin do for the analyst in any organization? The activities are primarily divided into three aspects: predict, diagnose, and forecast. Taking a closer look, on the left-hand side, we see that traditional time series data trend looks like coming from a monitoring um, condition on a piece of equipment, in this case, a compressor, where you can see the tag data is giving you an idea that there is a reading coming from a bearing of a compressor, right? On the right hand side, what you see, if the same piece of equipment had a digital twin to model what ideal behavior should look like, which we term as a dynamic band. These models are built on your historical operational behavior, operational states, system conditions, ambient temperature, whether it is working in a desert, it is working in the Arctic, or any other relevant data. Based on this data and the incoming tag input, which is anyways a representation of your DCS or PLC systems through your historian, the system should be able to tell if there are any deviations from the best operating band, which we have already defined as a dynamic band. If the residual value falls outside of the threshold value, either high or low, an alert will be displayed on your watch list. This is indicated by the cross in the diagram, right? A certain number of alerts are expected to appear periodically for any given sensor, which is normal. Not every alert needs to be addressed, right? We all know that. Sensors can have spikes or display other behavior that does not need to be acted on, right? Mean there is a problem within the equipment doesn't mean that. Small deviations in data are expected and it's quite normal. In essence, large deviations in data are considered abnormal and then flagged as an alert status. It is important to remember that alerts are triggered off on residuals and not on actual values. However, single tag data, which in that case a bearing temperature, may not be sufficient to predict the failure accurately. You will need multiple indications and compare different parameters in order to arrive at a credible diagnostics based on which you can forecast the failure data. Data from multiple sensors help your predictive systems or tools understand how the equipment is being operated, whether it is under heavy load or light load, at high pressure or at low pressure, right? These predictive systems learn how these sensors should move relative to each other. Take this example where, and this is an actual live case for a compressor where our analysts, uh, when they monitored these assets from the remote monitoring center, they found a spike in the bearing temperature. And because the spike was in beyond the dynamic band, they raised a priority for case, right? Which means that they have got a local bearing problem that was flagged. And once that was flagged, we had a complete watch on how this is behaving and progressing. Then what happened here is that within a couple of days, we could see that there was a drop in the lube oil pressure and also an increase in the lube oil temperature. So if you look at individual spikes in isolation, they won't give you that picture of there is a problem of cooling loss. But because of multivariate diagnostics, which is basically a dynamic empirical analysis, so what we came to know that there is some serious issue with the bearing, right? And then we immediately increased your alert priority to priority 2, right? Thus giving an alert and an advisory to the site personnel that if they can go ahead and check whether everything is right or wrong for that particular asset. Then what we did is that we analyzed further and then we try to check that with this kind of analysis, when are we hitting the time to control limit breach, right? So we found that with this operating condition and with operating parameters, we are going to hit the breach date in 10.8 days. Thus, giving the field personnel, the maintenance personnel, the reliability analyst, reliability engineer sufficient time in order to take any corrective action and thus prevent any failure, right? And this case, there was a cooling loss because of an obstruction in the cooling water in the cooling line. So what it does here is that in this alarm forecasting, we use the linear regression models in order to enable forecasting. And then by doing this, we can know for sure when are we going to have the next control breach. Now, to sum this up, how this system helps the analyst sitting in a remote monitoring center away from the asset control what is happening on that particular asset. The analyst is looking at multiple sites, assets, and numerous tags. It's nearly impossible for a particular individual to focus on a particular asset amongst multiple assets and its tag values. If it is possible, right? If it's possible to do, then the time to react or time to action is compromised. It pertains to how quickly you predict, diagnose, and forecast a failure at the end of the day. These digital twin systems help the analyst with specific information on the priority cases, which then helps the analysts, the reliability engineers to take actions at an appropriate time in order to avoid any failures. The analyst would then be able to tick all the check boxes with respect to a robust maintenance, predictive maintenance regime. That is, you have predicted the failure early, you have diagnosed accurately, and you can forecast the control point breach date. G Digital Twins have been providing substantial value to our customers around the world. G Digital has been monitoring a lot of assets for clients through its remote monitoring centers across the globe and providing advisories on critical assets where these systems are deployed. In many cases, G Digital has supported clients set up their own remote monitoring centers and train analysts to carry out the diagnostics and set up assets for monitoring as well. This has helped clients set up their deployment on an enterprise system level and do it at a very, very faster rate. Just to give you a snapshot, and these are all the statistics where we are monitoring the assets within our monitoring centers for clients all around the globe. We have been helping client avoid maintenance and mechanical losses more than $1.6 billion in value, just to quantify how much we have saved for our customers. As customers have been able to have a return on their investment in less than 3.5 months, and we are very proud of that. That the investment which the customers have done, they are reaping the fruits from those particular investment. And we have been able to avoid any kind of mechanical losses for actionable notifications up to a tune of 60 million dollars. So the value from this perform digital twin is huge, depending upon how you want to set up within your organization. We can do it through our remote monitoring centers, or we can help you in creating your own centers, right? Yeah, there are a lot of questions which is normally asked to G Digital, because primarily G Digital have been forefront in the asset performance management programs. And then clients have been asking, how does your predictive tool sits and how does it help in your overall APM program? The answer is it it sits very tightly and seamlessly in our overall APM program, especially on the analytics and the action domain. So what it does here is that it helps you in having a holistic view of the asset health. It removes silos from your conditional data sources by integrating your existing data with your predictive data coming from your predictive tool. It also helps you in having a single source for all of your actions, because the recommendations coming from your different tools can be integrated into a centralized platform, and there you can prioritize your actions and then you can execute those actions. You can also help your maintenance strategies by inputting the data from your predictive tool and move your asset strategies from a time-based maintenance practice to a condition-based maintenance practice using your APM tools. And predictive diagnostics and data can be an input to those tools within APM. Also, the root cause analysis. When you have the data coming from a predictive tool, it links your failure events, it links your diagnostic events to your root cause analysis programs. Thus, it helps you in moving you up higher in the PF curve. Now, yes, you have analyzed your data. You have got your data into APM. You can visualize your data. Then what you do with that data, right? So let me give a simple example, a case where you utilize the data coming from the example which we gave to you, which is basically your cooling loss, right? You get that information from your tool, which says that you have got 10 days to execute your actions or to take some necessary steps. So then what we do here is that you look at your outstanding PMs, whether you have got any existing task which you have not completed, or if you have completed, then what are those some summary of the inspection which you have done, what are the findings which you have got. You can go back and check it once again, and if everything is good, then you can also go for another round of your condition-based, inspection, right? You can have a route, a rounds where you can go to the field and check that whether you are able to see any anomalies, right? Any anomalies in your asset. So now this will validate what data you're receiving from your predictive tool. So now, once you have got that, you can prioritize the activities for that particular asset. You can assign a higher risk or lower risk depending upon what you have identified based on what you have got from your diagnostics and what you have seen on the ground, right? And thus it helps you in managing your resources and planning your resources in a much more effective manner. We will try to showcase this particular case for one of our clients, which is Total. So they had a lot of issues with their turbines and compressors, right? So what they found out that um, 22 out of the 71 breakdowns on their turbines were could have been anticipated, right? And that could have been prevented, but they could not do it. Similarly, for centrifugal compressors, 28 out of 34 breakdowns could have been avoided, and they could have anticipated that. So what they did was that based on this information, they went ahead and they selected G Digital's predictive tool, the Smart Signal, in as one of the tools which would help them in the predictive journey. So they set up their own center for for this remote monitoring, which they term it as RAID, RAID, Remote Assistance Intervention and Diagnosis. And we help them in setting up that remote center. And statistics show for itself from 2013 to 2019, 2020, based on the information which we have, they have got zero breakdowns on the monitored fleet, both for gas turbines and also for the compressors, right? So this is something which we are really proud of, and we have been able to give a lot of value to our customer, especially in this case, Total, and they have been very supportive in our journey, right? We'll also take the case of one more client, Gerdau. So there they had a lot of issues with respect to production losses, increase in the maintenance cost, and they wanted to move from a time-based maintenance to a condition-based maintenance regime. So they had 662 monitored assets across the globe. So they deployed 35 models, and with partnership with GE, they had got a lot of blueprints which are specific to the steel industry. They had close to 20,000 sensors, and they asked GE to help set up their asset monitoring center. So what we did over the years is that we have successfully helped them in avoiding losses. Um, we have managed to avoid a lot of catastrophic failures in the last 3 years. We have been able to reduce the cost of um, maintenance by 10 to 15%. And then we have been able to increase the condition-based maintenance plans and decrease the time-based maintenances by close to 5,000 hours, right? So these are very big numbers for an organization of such magnitude. Apart from that, we have got a lot of other use cases where we have implemented APM, Smart Signal, G Digital suites in order to improve the maintenance practices. And in this case, for South 32, we have improved top line revenue. For BHP, we have been able to have, you know, um, we have been able to generate a value of by giving them all those tools which can save them and solve a $1 billion problem. We have been able to identify bottlenecks and equipment issues and have been helping them to avoid unplanned downtime and increasing efficiency. With Rio Tinto, one of the major mining clients, we have been able to reduce unplanned downtime, increase uptime, decrease cost, and reduce operational risks with APM, right? So, um, Lastly, how do you get started with the predictive diagnostic and digital twin journey? You can get in touch with us. You can get in touch with our consultants who have who are all around the globe, whether it is in Australia, whether it is in APAC, whether it is in Middle East, whether it's in US, and then they will be more than happy to understand what your business case and value use case is. Based on that, we should be able to design a program for you where we can fit in your predictive program with our digital twin program and derive a lot of value to your organization. For any further information on G Digital and G Digital products, especially on digital twin, please visit g.com/digital, and please feel free to get in touch with me or any of your country associates. Um, or you can reach out to us on this website. We'll definitely reach out to you ASAP. Thank you for the time today and hope you had a very informative session. Over to you, Sheldon.
Excellent. Thanks a lot for that, Rajesh. It's great to see how GE is using digital twins to optimize processes and improve efficiency for your clients, and especially pleasing to see that technology continuing to be adopted by the mining industry. So thanks a lot for running us through that. We do now have about just a few minutes for audience Q&A. So I would like to start off with this question here. So in the context of mining, what are the specific assets for which GE digital blueprints are ready to be implemented? And how quickly can you implement these blueprints to the similar assets within any organization?
That's a very good question. What happens here is that we have got blueprint for almost all the assets in the mining space. Uh, what I can say here is that we have got blueprints for haul trucks, blueprints for stackers, reclaimers, dragline excavators, ball mills, crushers. We have got almost all the blueprints which is required in the mining world. As well as we also cater to blueprints on the refinery and also in the smelting side, where we have got blueprints for pumps, compressors, which normally we are close to more than 500 to 600 blueprints across all the assets and asset types. Especially for the metals in the mining world, we have got exactly, uh, we have got a lot of blueprints. We have got blueprints for bucket elevators, conveyors, and all of those items. Also for metal sectors, we have got screens, vibrators, apart from pumps and other generic items. Um, so to answer this question, we have got blueprints for almost all of these assets. And for some cases, for some of the assets within the mining and the metal sector, they would be specific for that particular work process, because you have got a lot of elements, you have got a lot of metals which has to be extracted. So what we have is that I consider our blueprints to be Lego bricks. In case you have got any specific asset, we have got the individual components, or I will term it as the Lego bricks, which can be used. And for that particular asset, these small items can be used for deriving a blueprint for that particular asset. So for any asset which is for which we have to generate blueprints, it is basically we consider this to be a derivative kind of a blueprint preparation. So that's what I can very well answer to this particular question. And then how do we fastly implement it? So now, because you have got these blueprints ready to be implemented, so the time to get this blueprint churned out for your assets is very minimal. So we don't have to do any modeling at the back end. Those modeling are anyways present as a part of the blueprints. Is that you have to map the tags, do some final tweaks. You have to train the model, and then the model will be ready for you to use. So the time to response is very fast. And because these blueprints can be applied to multiple assets, it can also be scaled, as I said in my presentation.
Excellent. Thanks for that, Rajesh. We
Okay.
might just get to one or two more questions before we go, as we do have quite a few there. So, a question from Partha here. So, are SCADA tags, vibration, and oil analysis, I guess, in one place, along with assigning actions? And does it speak with third-party tools such as Power BI and CMMS?
Okay, that's a very good question. So what we do here is that because this L0 and L1 data which comes from your SCADA, all this data we assume it's going to your historian, right? And from historian, what we do is that we have got our connectors, data collectors, which takes the data from these systems and then push it into our tool. Okay. Now, we have got the dashboards, we have got the visualization where we can see all the tags, we do the mapping. So when we do the initial integration, we do all these mappings and you can view all these data inside a smart signal tool. Okay. So if you look at the complete APM as a product and as an application, smart signal or our predictive tool sits within the reliability bucket, right? So we have got tools by which you can visualize this data. We also have got tools which can connect to your other data visualization tools like Power BI. And also we have got standard connectors, which is connecting to your CMMS system like SAP and Maximo. So we have got all these things embedded into that application. We will be more than happy to share more information on the product. Please feel free to drop in an email. We should be more than happy to tell you how we integrate with all these third-party systems and vendors.
Wonderful. Thanks, Rajesh. And we'll just get to one quick last question before we go. So, how does the GE platform help with investigation and diagnosis? You showed a case with a proposed cause, but how is the confidence for this cause provided to your clients?
Correct. So as I said in my slide, that is a very good question, by the way. So what we do here is that we have two ways of handling this, and we have got specific ways to handle client level information. So we can diagnose, we can predict all the failures from your side based on the data which we monitor at our remote monitoring centers. We can do that, or else we will train the clients to take much more proactive path in getting the diagnosis done by themselves, right? So what we do here is that we have got the tools which we set up for the clients. Initially, we train those models. We do it for you at the first year. Normally, we do it for the clients in the first year, and slowly we train the client reliability professionals, reliability engineers to take this remote analysis into their fold. So we have got all those programs in place. So we have got a team of reliability experts, consultants who are day in and day out doing this work. So we have got tools within Smart Signal and also in APM. See, we know that a lot of organizations in this world are not mature in terms of their maintenance regime. So we have condition-based. We have CBM level 1, CBM level 2, and CBM level 3. These are the three different levels where our whole APM suite works, and Smart Signal is also part of those APM suite. So that helps in visualizing, predicting, and forecasting your failures, depending upon what is the maturity with respect to the sensors, because we all know that in predictive tools, the primary thing is the sensor and the sensor data. So it's a mix of all of these things. You can have a lot of sensors on a particular asset. You can straight away go and put your predictive tools. In some cases, you might not be having that. You might have to depend upon your field level instruments or the field level data extraction. So for that case, we have the smarts inbuilt into the system, which can take this data and give some automation alerts or can generate automated actions based on some logics, which the users can themselves create. So there are a lot of things within this APM and within the smart signal predictive tools. We feel more than happy to help you, more than happy to give further information on these tools. Uh, Please directly reach out to us.
Excellent. Thanks a lot for that, Rajesh. And yeah, so thanks a lot for your time today. And as Rajesh mentioned there, for those in the audience, we will be following up with an email to you this afternoon so we can provide some more information and also the information for Rajesh. That will also have a copy of the recording and the presentation as well. So you can expect that in your inbox this afternoon. Once again, Rajesh, big thank you and to the team at GE for this session. It's given me a great overview of how digital twins are being used in mining and related industries, and I'm sure the audience found great value out of it as well. So thanks a lot for that.
This is all mine. Thank you so much for giving your time as well. Hope you have a nice day.
Excellent. Thanks everyone for tuning in, and we'll see you at the next webinar. Stay safe.
Thank you. Bye.